Hey everyone, and welcome to my episode on the microlith. Now, this is the newest and what I would call probably the most prevalent service architecture found today in the wild. Now, I see a whole slew of tools that struggle with the same abuse that we're going to talk about today. But today, we are focusing on microservices. If people like this one enough, maybe I'll do other ones on Kubernetes, Agile, Full Stack, Distrolist, Helm, and a whole lot of other tools and concepts and other ideas that I see mutated into abominations of their former selves. So make sure if you like this to share it with your friends and hit that like button if you want to see more topics like this one in the future. Let's start with a little clarification before we get into the guts of this conversation. When we do one of these type of videos, it's not because I dislike the concept or am making fun of any one person. It's because I hate how people abuse it and turn it into something that it's not. Not only that, I don't want anyone to get the impression I'm insulting anyone. I'm not. I'm merely trying to help where I see teams go wrong. So please, let's keep it nice and civil in the comments. So what abuse do I see in microservices? Well, to understand an abuse of a system, you really need to first understand what that system is. So let's talk about the issues microservices solve and figure out what a good definition of a microservice is. Please don't leave right now thinking that this is going to be boring or that you already know this, to the point that this will be boring to understand microservices better. Are you really a nerd or not? Do you want to watch this entire video just to prove me wrong? No matter your reason for watching, it is of the utmost importance to have a clear understanding of what something is, to then understand the problems it solves and what problems it just, in fact, does not solve. And then with regards to the assumption that you already know what a microservice is, I would argue that the number of incorrectly made microservice architectures out there would refute you better than I ever could. But hey, that's just me. I don't say this to be mean or throw anyone under any bus. I say this because I find that all too often, software engineers latch onto ideas that these large companies use to solve a very specific problem, not really fully understanding the problem space it was designed to solve for that company, or even why it solved it in the first place. Furthermore, I too often feel like I would be shamed, feel like you were unhireable or just wrong if you said you did not use or want to use microservices. It's such a hot buzzword, everyone feels pressured into using that term because if your architecture is not microservice, not only are you not cool in any way, but you would fail many or most architecture interviews. But I would refute all of this and say that most of you don't actually implement microservices at all in the first place. And if I ever ask you a question about microservices in an interview, I would expect for you to understand why we use them. So, have I piqued your interest just yet? I might have more aptly offended you, but this is the life that I live. I am the YouTuber you need, not the one that you want. I say all of this because I want you to think for yourself. And trust me, I am one of the first ones wrong on some or maybe even many of these ideas. It's okay to be wrong, and it's one of the ways we grow and learn. Go check out my other videos on making mistakes. And you know what? I'm not even immune to this bandwagon issues, as sometimes the ideas either sound so cool or solve a problem really similar to a problem I have, though I do try to fight this primal urge. Computer science is just that, science. It should be a place where simply we have a problem, we come up with a hypothesis based on research, make experiments and run them, and draw conclusions based off of analyzing the data we get from those experiments. And then we get some more problems and make hypotheses, experiments, and conclusions. It should be an ever-rotating door of knowledge, meaning we should always be evaluating what we are doing and why. And it's solving the problem well, and if we could solve the problem better. The code I write today should undoubtedly be worse than the code or ideas I have tomorrow, as tomorrow's Merrick gets to build off of all previous mistakes. So Merrick, what is a microservice? Well, just to be clear, these terms are not something I just made up to make this video. To prove my point, we'll be using a few readily available sources you can look up for yourself to help us not only define what a microservice is, but also give us a glimpse into what problems they're solving for these companies. Here, we can see that AWS says this about microservices. Characteristics of microservices. Autonomous. Each component service in a microservice architecture can be developed, deployed, operated, and scaled without affecting the functioning of other services. Services do not need to share any of their code or implementation with other services. Any communication between individual components happens between a well-defined API. And then it further goes on to say that each microservice should be specialized. Each service is designed for a set of capabilities and focuses on solving a specific problem. If developers contribute more code to a service over time and the service becomes complex, it can be broken into smaller services. And then further on, we can find in the Microservices Architecture book, the authors conclude that a microservice should be small in size, messaging enabled, bounded by context, autonomously deployed, autonomously developed, independently deployable, decentralized, built and released with automated processes. Now, to be honest, I am much more of a fan of the AWS definition as it has less fluff and ambiguous terms. I think this is something books do to try and get you to actually read them. It's actually kind of a form of clickbait. Hey, what does messaging enable even mean in this context? And how does it have anything to do with microservices? I'm going to have to read that book. Or like the last point from the book, built and released with automated processes. I honestly think this is a complete stretch and disagree with the authors. But even so, it's still a fantastic book, even though I don't 100% agree with everything they say. Now, mind you, I'm not saying that you should manually release your code. I'm saying it does not really pertain to microservices or what they're trying to solve. But I rabbit hole here. All right, so do you need more from other people or is that enough? If you want more, do some Googling. But let me sum up the highlights for now. I'm even happy to throw away ambiguous terms like small in size and messaging enable. Keep the core concepts simple of any idea and move on from there. The other ideas make sense once you have conquered the root issue. Things like small in size, I don't think this really matters that much. It's more about doing one thing and doing it well. If that one thing happens to be larger than another one thing, it would make sense that that one thing would be larger than the other one thing. And so it doesn't really help us to argue about how big is too big. But this one thing principle isn't a microservice thing. It's a whole computer science thing. So stop throwing it in every single book about computer science. Computer Science 101. Have your thing do one thing and do that well. It's right on the first page along with fail fast. So nothing else needs to claim it as their own, and we get it. Let's move on. Now, that being said, I myself too often have gotten tangled up in conversations about how big is too big. And the answer really comes down to this. You will know when it's too big. Don't worry about it. Just stop worrying about it. You'll know. So while I digressed a little, I thought it was important to cover to ensure you understand I'm not leaving anything out that is important. When putting this video together, I made sure to look over all the different aspects and boil them down to what problem microservices look to solve. If not discussed, then they were not deemed mostly relevant to this topic. Not that they're bad practice, mind you, but irrelevant to the topic at hand. Let's define the pure essence of a microservice. A service that can be autonomously developed, deployed, operated, and scaled that is specialized with each microservice designed for a set of capabilities and focuses on solving a specific problem. Let's think about what problems these things solve. Because all too often, when I ask people what problems microservices solve, they say scaling. And honestly, they could not be further from the truth. Let's dig into autonomously developed and independently deployable a little bit and try to understand what problems these things are looking to solve and why scaling is not on that list. Autonomously developed and deployable seem to be easy, but what problem is it looking to solve? Again, if you said scaling here, I would call that wrong. The ability to scale has nothing to do with autonomously developed. It literally means with the freedom to act independently during development, deployment, and scaling. This is one of the main issues microservices are looking to solve, and it comes down to this. Managing a small team is easy. Managing big teams is hard. You are more efficient the smaller the team, with less management overheads. So being able to keep a team small and independent in really large companies is really important. The only scaling this revolves around is the scaling of your workforce, not your application. This represents how your business works and operates and governs how you can divide up your teams and how they communicate. What does this mean? This is about defining how your teams in your company communicate and making your applications reflect this. Microservices are looking to solve a business issue, not a code or technical issue at all. Now, while this does not have its roots in solving any technical problem, this does have some technical implications with regards to your code. You can't have dependencies on another team. Your team owns it and is responsible for it. So this is all about business organization and communication between teams. Now, it's not always obvious, but where I see this go wrong most often is when a small team owns multiple microservices, or even worse, when multiple teams own multiple overlapping microservices. Now, I know that some of you are going to argue that in a serverless world, you could have 100 services per person. Maybe. But did you actually reduce complexity? See, I find I could write most applications simpler than their serverless alternatives. Does serverless have its uses? Absolutely. Can you design your entire stack off of them? Sure. Should you? Probably not. Another place I see an issue in production with this is code sharing. Code sharing sounds really good, right? Well, the problem is when you share this code, whether it's object, serialization, or some logic, your microservices are now inherently linked and not independently deployable. The issue becomes that making a change to that library changes any and all microservices that use it. You might try to argue that one microservice could just not update to a newer version. And you would be right. But now, what if that service wants to make an update to the shared code? Now you have two branches. Again, this goes to my point that microservices are not made to save time or effort. They are actually increasing effort. If you are breaking things apart into smaller pieces just to make them smaller and more complicated, you have to ask yourself, what problem are you actually trying to solve? Again, if you say scaling, I'll ask you to prove to me where you can't scale and how microservices solve that issue. In the vast number of cases, it's due to other problems. Again, scaling horizontally is solved by stateless applications where you remove the state from your application, typically storing this state in some stateful application like a database. And your number one job should be to make it as simple as it can be and solve the problem at hand. And sometimes, especially in small teams, I think this might just be a few larger monoliths. And trust me, a few well-defined monoliths are better than microliths. As someone famous once said, I must not microlith. Microliths are the mind killer. Microliths are the little death that brings total obliteration. I will face my microliths. I will permit it to pass out of my systems. When it is gone, I will turn the inner CPU to see its path. Where the microlith is gone, there will be nothing. Only my service will remain. Remember, solve problems you have, not ones you might have if you ever figured out how to deploy your 192 microliths. Also, remember that these microservices that you're trying to create are formed around small teams. If your entire development team is a small team, there is no business need to split it up any further. So please, for the love of all things good on this earth, stop it. Let's move on to other important statements we identified earlier. They also need to be independently deployable and scalable. I group these two because really, if it's independently deployable, it also is independently scalable by nature. Scaling is kind of a subset of deployment. This is another place where I see so many people go so wrong. If you want a microservice architecture, you have to make it independently deployable. First, let's try and understand what problem this solves. This one seems to be just a little bit more straightforward, I think, but I think a lot of people get caught up in horizontal scaling again. As it turns out, this looks to solve the exact same problem that independently developable and deployable look to ensure. This ensures that your application can be deployed, scaled, and managed by independent teams in isolation of other team services. This is because teams that use your service have no idea how many other teams use your service, meaning your team can act and move independently of any other team. Again, this looks to solve a business management problem, not a technical problem. Sure, it means you have to scale it independently of other services, and this does bring its advantages, but you really have to be a company that can leverage those advantages before that even ever matters. And I would say that it matters way less than some people make it claim, except in the very small edge cases. It also has technical requirements to support the business requirements as well. It has strict requirements for how things have to be designed and dictates how you can depend on other teams and other projects. I personally would insist your microservices be deployed independently, not just be able to be. And this forces your hand and ensures it does not become accidentally entangled in another service that you deploy. It's vitally important to ensure these boundaries are maintained, as without them, you will experience the return of the microlith. What does this mean? It means that your service needs to be versioned on its own, deployable on its own, that you can update and deploy it on its own. And it must be implementing a messaging API for other teams to use, meaning no other team needs to be involved or consulted with. It means your microservices needs to have an API, and that API must be versioned. It means that your team or company needs to have a deprecation policy so that if you want to stop supporting an API, other teams that use your service should have a support window. It means that other teams in your company use your service just like they were outside of your company. You don't deploy your services together, you don't scale them together, your teams don't need to meet, and they don't need to get lunch on Wednesdays to sync. Let's move on to our last statement. They're specialized. Each service is designed for a very specific set of capabilities and focuses on solving a specific problem. I think this is a bit more nuanced than the others. Why? Because this is looking to create team boundaries. Boundaries, you say, isn't that bad? Is everything about a microservice about team structure? Yes, that's pretty much my point. This looks to foam ownership to make it easier to understand whose problems is whose. If you're looking to add a new feature, what team should implement that feature? What service does it go in? This lets us have well-defined product ownerships and responsibilities. One of the most important things this enables is the easy rejection for features and capabilities outside your service's specialization and requirements. And again, do one thing and do it well is Computer Science 101. If you want or need a video on why that thing is so important, let me know and I'd be happy to make it. But let's not keep adding to other things. It's its own thing, trust me. So this brings me to the formation of the microlith. The microlith is the #1 service deployment architecture used today. This architecture is when you build a monolith in a very distributed, split up, hard to debug way. When you take a monolith, break the code into 20 repositories to make it almost impossible to debug and reason about, requiring at least all 20 repositories to build and run to make it do its thing. Each part of the microlith depends on at least 4 other shards of the application. This is the microlith, the plague I too often see eat at small teams doing this cool microservice things. Then to make this even worse, I see them adopt something like Kubernetes in an attempt to fix their microlith issues, thinking that the only reason their microservice architecture is sucking is due to the lack of using the tools the big companies use. When in fact, now they just added more pain to their microlith architecture. Because of this, I have put together a helpful guide to help you spot microliths in the wild. Help stop the spread of this dangerous microlith. Here is the hacker's guide to the microlith. So if you have 4 microservices that need to be updated and deployed at the same time because all 4 of them are interconnected and require being updated because they were not decoupled, you might have a microlith. If you find yourself debugging code in another project to make your project work, you might have a microlith. If you run a Kubernetes cluster on your local machine to test your service, you might have a microlith. If your API is not versioned and you find that updating the API in one service requires updating and deploying other services, you might have a microlith. If you find yourself owning 42 microservices as a team of 2, you might need a new job. Microservices are hard to do well, and they don't make things easier. They don't solve scaling. In fact, they're not designed or created to make things easier from a technology standpoint. They usually make the big picture view of your system much more complicated. They were designed as a way to structure teams in large companies to make teams from depending on each other. They actually take more human power to produce the same result, not less. Now, Merrick, did you just end your career? That's a solid maybe. Absolutely maybe. Hopefully my boss doesn't watch this video. I wanted to make it clear I'm not saying microservices are bad or don't make sense. My argument is that most people don't even really do them in the first place and don't leverage them properly. And in fact, the microliths they create are worse than the thing that they were actually trying to avoid in the first place. Trust me, you say that monoliths don't scale, but I would argue that you can scale them just fine and just as easily as long as you don't keep state in them. And you can have a stateless monolith and it will scale just as well as you need for now. Have you ever tried to really scale a microlith? Have you ever tried deploying one? The number of negatives far outweighs any benefit you would ever be able to prove you obtained. Stateless monoliths really just don't have independent little parts that scale independently. And while it's cool to be able to scale just this little small piece, the thing that you need, this really actually is a lot less useful until you reach a massive scale or your app has some very unique special needs. I don't say this lightly either. I have seen and actually contributed to this myself. I too did not understand what a microservice architecture actually meant at one time. I did not understand scaling and what enables it, and I have written some of the most horrible code that is probably still in production. And this actually absolutely terrifies me. Anyhow, the whole point of this small rant was that before you pick up any tech whatsoever, make sure you understand the problem it solves and why it solves it. Microservices solve a huge problem when it comes to managing massive workforces and splitting up work into teams or cells and ensuring that these teams are able to act independently. It also makes sense to letting them work independently of each other, and it works really well to keep the teams agile and able to move forward with their goals. When it is actually used, if you have a small team, please, it's just extra overhead. Yes, it's cool to be cool, but we're nerds. We abandoned being cool quite a long time ago. Be different. Remember this. A complete working project is way better than 10 half-made microservices that all need to be deployed independently. Don't let anyone shame you for not using the latest and greatest cutting-edge Google technology that was not designed to solve your problem. So what is my recommendation? What should you use instead of microservices? Well, the answer is do your job. Your job should be to develop things that solve the problems you have right now. It's quite possible to build a few well-designed monoliths that would be easy to split up once it makes sense to. And if they are not maintaining state, these services will be fairly easy to break up when the time comes. But the truth is, it's important to understand your problems and understand what problems are solved with specific techniques. The real answer is, don't let anyone tell you what is the way to solve your problem. Understand that everyone is telling you how they solved one of their problems, and then make experiments about how you can solve your own problems. I love knowledge sharing, and that is why I spend all of the time making these videos. but I would encourage you not to just take my word as necessarily what will work for you. They might have worked for me in the past or currently. You just need to ensure that my excitement for a technology does not encourage you to adopt something just because I'm excited about it. Ensure that you have the same problem and that it solves that problem. It's fine if we both don't use the same solution. For example, I love Kubernetes and containers, but I try to stress it's not necessarily for everyone and does not solve everyone's issue. And it's important to understand that what problems it solves and ensure this lines up with the issues you're currently trying to solve. Not only this, most solutions have their own trade-offs, Kubernetes included. In the example of microservices, it's the extra human power and effort to maintain and deploy these services, as well as the added complexity to your system as a whole. Once you understand this, you are able to more effectively leverage microservices. Not only this, I hope this encourages you to think about why you are using microservices in the future, and maybe you and your teams can come up with a conclusion that a simpler design is better for the time being. I am absolutely a huge supporter of the concept of KISS, which is keep it simple, stupid. Only add complexity when it solves a problem that is more painful than the complexity is. This is the understanding that will empower you to fully leverage microservices, as well as being able to understand how scaling works a bit better. That being said, if you like this and you want to do more videos where I tear apart beliefs you might hold dear to, go ahead and like this video and subscribe to my channel so I can tear apart more of your popular beliefs. The next video might just be on Santa Claus. But if you did not like this video and don't like feeling mentally stimulated, go ahead and subscribe to that other tech YouTube channel for science.